Principle number 3. Principle number 1, eliminate tillage. These are regenerative principles. Principle number 2, never leave bare soil. Principle number 3, some plant diversity is better than none, and more is better than less. And ecologists hate it when I say that. You can't just say, make a blanket statement about plant diversity. I'm like, you can't after you've seen enough systems and not sat at your desk. Plant diversity supports biodiversity. Almost every other element of your biological system is directly tied to how many plant species are in it. Bacteria, fungi, insects, animals, mammals, birds, all of these organisms that you need on your farm. Biodiversity isn't great because we love species. Biodiversity is good because it does things. Okay? It provides services that you need on your farm. What are some of these functions? That's where your soil comes from. Incorporating residue, bringing plant material down in, stirring that soil up. Increasing seed set on your crops by pollination services. Suppressing crop pathogens through competition. Driving holes in the soil so that you've got water infiltration, so that the water is available to you when you need it. And then managing insect pests, which is the one I like a lot. Why do we need species? Why is diversity so important? A community is like a puzzle. And all of the species interact with each other to form this community, right? And then when you try to manage that, because agriculture is a damaging and disruptive process, I hate to say it, but it is. We have to eat, but we have to recognize that. As you disrupt that community, you start dropping pieces. And the only way is to have redundancy to fill those gaps up again. That's why diversity is so important. Okay. I'm going to talk an example of that. We're going to talk more about corn rootworms. I'm sorry, everybody, but the rest of the world really loves these things. So, corn rootworms, this is a beetle pest. As I said before, it is the worst pest of agriculture, the most expensive pest of agriculture in the world. And that's why we focused on it. It's been recognized as a pest for 100 years. And literally hundreds of millions of research dollars have been spent on this thing. But what we have learned is that no matter what we throw against the corn rootworm, it chews it up, it spits it out, and then it flips us the bird. And that is a good pest. Initially, we thought, okay, we're going to manage this pest using soil insecticides, right? Because it was invasive when we formed a land bridge with corn from Nebraska into the Rocky Mountains. That's where it came from, is the west. Okay, well, we've got this new pest. Let's control it with soil insecticides. And it never worked. It never really worked all that well because the insecticides didn't make great contact with the pest. And then the rootworms just became resistant to everything. So it didn't last for long. So they started rotating. They started rotating corn and soybeans. And that worked great for a long time. Because what happens is you got to understand the biology of this critter. This beetle loves to lay its eggs at the base of corn plants. And then what happens is that those eggs overwinter and they hatch the next spring. And the only plant that they really like to eat is corn. And so if there's no corn there, then the beetle larvae writhe in pain as they starve to death. So, it took about 30 years, but the corn rootworms became resistant. Not once, but twice. First, instead of overwintering 1 year, corn rootworms started to overwinter 2 years. Or 3 years, and they bypassed the soybean phase. The other ones, the other population, started to lay their eggs at the base of soybean plants instead of corn plants. And so they'd hatch the next year into the corn. That's a smart pest. Never fear, everybody. Don't worry about it, because the answer is all in the bag. It's all in the bag. You can just buy genetically modified corn seed, BT corn, that will kill the pest. And it took 3 generations for the corn rootworm to become resistant to BT corn. 3 generations is all it took.
They didn't think to test that.
And so that's why RNAi has come on, and that's why neonics have come on. Guess what's going to happen to those? Right?
Yeah.
They're going to fail. When I first started working on this, I started my career working almost exclusively on predators. I was a predator ecologist, which sounds a lot worse than it is. I was interested in natural enemies, and guys that spent their entire careers working on this one bug. And they said, there are no natural enemies of the rootworm. Okay? So we had to start kind of from scratch. What we did is, first off, we took those little pinned larvae, and then we put them out in these cornfields. Each dot is a cornfield. And what we found is that as more rootworm larvae were killed, the root damage in a cornfield, the root damage went down. So predators were having a pretty profound effect on how much damage those pests are causing. Dozens of predators. So what we did is we developed a genetic technique so we could take predators out of the field and we could cut off their heads and their butts and then rip out their stomachs, and then we'd look inside their stomachs for rootworm DNA. And we'd see which predators were actually eating corn rootworms out in the field. We identified dozens and dozens of predator species that were eating corn rootworms out there. So there's a lot of predation that's going on out there in the field. So what we wanted to do is we wanted to test how does predator diversity, as we increase the diversity of all of the species in that puzzle, what happens to corn rootworms in that situation? And the ecological sciences are kind of at odds over this, because as you increase the diversity in those cornfields, what are those predators eating? Well, they're eating each other. And so it may actually relax pressure on the rootworms and you may see an outbreak. But others say, well, as you increase the diversity, they're going to eat more rootworms. Okay, so it's a big debate. So we got 16 cornfields. We decided to test this idea out there. And we infested those cornfields with patches of rootworms with our handy-dandy egg infester. And then we took these golf cutters and we took soil cores and we brought them back into the lab and we warmed them up, and then all the insects that live in there kind of escape, and we collect them up, and then we take the predators and we tear out their stomachs. This is a beetle stomach. A damn good dissection of a beetle stomach too, I might add. Surgeons got nothing on entomologists for steady hands. Okay? And we analyzed 2,000 of these predator stomachs using this qPCR method, quantitative PCR, which is a genetic, it looks for rootworm DNA sequences. You know what the silver bullet is? It's a community. It's a community, because communities change. Over even a 24-hour period, insects will totally change in which ones are out there. They change over the season, they change in their redundancy, and they're working together, and they're always filling all of those different puzzle pieces in if you've got the diversity in your system. Okay? So this is the community, and this is the proportion positive per field. 6%. A lot of people would look at that and be like, boy, I'm sorry, John, that's very low. I was pleased with that number, because you have to understand the method that we're talking about here. So what we're seeing, so as soon as you eat like a turkey sandwich, or I had a BLT for lunch, it was delicious. As soon as I ingest that, I instantly start digesting that. So the DNA from my sandwich is only available in my tummy for a certain amount of time. Okay? It's the same with insects. It's about 8 hours that they digest a meal. And so 6% of the predator community ate rootworms in the last 8 hours. So when we went out and we only analyzed 2,000 predators, so 6% of 2,000 isn't very much, John. But when we do actual density samples, We were out at Dakota Lakes Research Farm, which is, was one of the real leaders in no-till adoption. You look at no-till adoption in the United States, smack dab in the center is Dakota Lakes Research Farm in Pierce, South Dakota. And it's because of a man named Dwayne Beck, who's really worth listening to if you ever get the opportunity. Extremely influential individual on a worldwide stage. And we looked at his fields, and we found that he had 1 billion predators per acre on his farm. It's the most I've ever found. We infested his ground, his cornfields, with 1,000 eggs of rootworms per row foot. Nothing came out. Nothing came out because he's got so much biodiversity out there. 6% of 1 billion ate rootworms in the last 8 hours. That's a lot of predation going on. Okay? But we got error bars, and that means that there was variability, which means that you got different pressures on that rootworm in these different fields. That allows us to explore this relationship of predator diversity and how many rootworms are around. Okay? As predators became, each dot is a cornfield. You're going to hear that a lot. Each dot is a cornfield. As the predators became more abundant in cornfields, they relied more heavily on corn rootworms as prey. As the number of predator species increased in cornfields, they relied more heavily on rootworms. Why would they suddenly decide that rootworms taste good? Only when they're abundant and diverse. We've all gotten one of these, I hope. Feels good, right? On Valentine's Day. The orange cream is always the last damn chocolate in that box, isn't it? Usually there's a bite out of it and somebody puts it back. We've all seen it. Anybody like orange creams? No. I'm sorry. The rootworms, the only way you get that orange cream eaten is to have a weirdo out there who really likes them, or you saturate that predator, you saturate that community of chocolate eaters, right? And they eat that one last. Rootworms are, they are the orange creams of the prey world. This is actually what my kids do whenever I serve anything with tomato sauce. They start rolling around on the ground. This is another thing that entomologists do for fun. Gladiators!
I never realized so many of my own.
One of my professors during my doctorate, one of my professors, Mae Berenbaum at Illinois, that's where I went to school. She's like, I'm doing a children's museum exhibit on beetles. So if anybody has any beetles, let me have your beetles, and I'll show the kids. And so she came out and okay, so here's our predator. And when you want the show to start, you put the caterpillar with the beetle. And so she comes back after a little while and gives me my beetles back. And I'm like, how did it go? And she's like, well, you actually scared the children. It was so grisly in there. Like, I had starved those beetles for a while. And they just ripped them to shreds. Another generation of entomologists wiped off of the. Don't have to worry about them.
I'm sure a few of them liked it.
Yeah, not the right ones though. So, what we found, and this is is that sucking predators that suck. So if you suck, you like orange creams.
Your guest all day.
Yeah, I don't want to know what this video is going to look like at the end of it.
Your guest.
So if you're a sucking predators, you love rootworms. Okay, the defense didn't seem to work against them as well. We've got a good. So we set up a little arena like this again, using wolf spiders. And so the wolf spider would like come up just like to the rootworm larva, and it would take a bite, and it would be like, "Oh, you taste like ass," you know, just like the beetle did, except it wouldn't run away and act like a ninny. it kept its foot right on there, its little tarsus right on there. And then after a couple of minutes, it would take another bite and would be like, oh, you still taste like ass. But it tended that prey item until it overcame the defense. Okay? So really cool stuff going on. And what we see is that the egg stage of the pest and the larval stage of the pest, those are here. And this is the prey consumption. So this is how closely they're relying on it. And you see that chewing predators seem to be adversely affected in the field. So if you don't view the orange creams as bad, you're not going to respond as you don't need to have a saturated predator community. You'll eat them no matter who else is in your community, right? And that's exactly what we see, is that the proportion positive is this flat line as diversity increases in the predator community in each of these cornfields. But with the rootworms, with the chewing predators, you see in these cornfields that you have to saturate that predator community before they'll rely on the rootworms. That's how diversity works. What is this? Does anybody else see this in other systems? It's mob grazing. It's mob grazing. You want to control weeds on your farm? You saturate them with herbivores, with ruminants. That's how you control them. You have to force them to eat the things that you want them to eat, at least until they learn. That's what's going on in the predator community, in your fields too. And unless you've got that diversity out there, they cannot perform their function. Your predator community isn't working. You've got to have species. Diversity begets diversity. It feeds off of itself, right? You've got to have species. And it all starts with plants. And plants can come in all kinds of different ways in order to make a functional farm. But it's got to be agronomically feasible. And there's lots of ways of doing that. And crop rotation is a really good one. And we've known that crop rotation works really well for a number of different pest species. But usually what happens is it's like the rootworm, where it's tied to that perennial nature of a crop. So if you plant the same crop again and again, the larvae are overwintering in the previous crop's residue or something along those lines, so that when you hit it again, the pests are already there. But it's not supposed to work if the pests overwinter someplace else. They leave the field because they have a choice of where they decide to come back to. They could come back to your field or they might not. So changing these crops breaks disease and pest cycles. But what happens when you monkey things up with to these pests that overwinter elsewhere? So soybean aphids, we decided to test this idea, and it's really one of the only times that I've seen it in the literature. I had a hell of a time backing this paper up with any of the previously published work. We looked at soybean aphids on, which is that primary pest of soybeans, but it overwinters on buckthorn. So we introduced soybeans from Asia, and then we introduced buckthorn from Asia as a shelter belt tree throughout much of the U.S., and then we introduced the soybean aphid from Asia, and then we introduced the Asian lady beetle, the multicolored Asian lady beetle, as a primary predator. So we've got a whole Asian ecosystem that's is basically our soybean field at this point. Anyways, the aphids don't overwinter in soybeans, they overwinter over here. So what happens to them? So we decided to test this, the effects of crop rotation and plant diversity in sequence like this. So we used this spring, so in year one, in the spring, we planted this OP mixture or a spring wheat. Now we harvested those, and then we planted a fall or winter cover crop of a barley radish mix. And it was the same in both of these. And then we followed that the next year, in year two, with soybeans. So really, the effects that we're testing here are the effects of two previous crops. And we counted the number of aphids per plant, and then we swept for all of those insects, those predators that might be living on those different soybeans that followed the different spring crops. Just by varying the previous year's crop, we saw, and doing it in the right way, I guess, we saw up to 75% fewer aphids on soybeans. That's better than a lot of insecticide control. Why? Well, we don't know. To be honest with you, we don't know. And that's so frustrating from a scientific point of view, is that for a lot of the reasons why these regenerative systems work, we have no idea in a lot of cases. I mean, we could talk about, the philosophies, but in terms of mechanistic studies, I mean, that really validate this, we're following behind the farmers on this one in a major way. Science is just scrambling to catch up, or at least they should be trying to scramble. We also looked at predators. And this may be part of the issue, may be part of the answer. This is your multicolored Asian lady beetle. They've got a W or an M, depending on what your perspective is. That's how you tell them from other lady beetles. This is an Asian species that likes to overwinter in your house and bite your children in the night. This is aphids per predator here, and what we find, so this is the ratio. You want you want very few aphids per predator, okay? You want a lot of predators for every aphid that's out there because that's how many they're going to eat. So what we find is that the spring wheat, the one that had fewer aphids, had a much better ratio, okay? We see a lot fewer aphids per predator in those systems. So predation may be one of the driving factors. It was really interesting because the study, the plots were almost on top of each other. They weren't like, the predators could choose wherever, and the aphids could choose wherever they wanted to go, and so for that reason we ended up seeing this. There wasn't like it was just really surprising results. There's a legacy of diversity that we often forget. The decisions that you make today may not affect you this year. It may affect you many years down the road, and that's something that you really need to be considering as you're developing your systems. Finally, diversity does not just include plants, it also includes livestock. Why is livestock such an important component? Livestock are a tremendous tool, and plants and animals did not evolve in separate systems. They evolved in the same place at the same time. They work together. You gotta have them together. Number one, livestock add an additional revenue stream to a parcel of land. I just got back from one regenerative almond orchard down in California. They were making more money by grazing their broilers underneath their almonds than they were off of the almonds themselves. Okay? So it's that, but it's also a tool. What a valuable tool. Why would you throw tools away? Especially when they're a valuable member of an ecologically based system. They are essential for nutrient cycling through production of dung. I make money off of my weed control by having sheep in my system. Why would I spend money to manage weeds? That's dumb. I want to make money off of that. Insect management. Chickens are great. But you got to manage things right. And I think that this is something that we often forget, is that animals also work together. So in our own farm, we're integrating this year, and we're going to try it. I'll let you know how it goes if you ever ask to see me again. We're going to try integrating pastured pork with our pastured lamb production in the same place at the same time. And then usually the chickens follow through. I mean, I do not have dung accumulation. My dung is gone. All of those fecal parasites do not exist on my farm. They're usually gone within 4 to 7 days. I don't have to worry about any anti-helminths, parasiticides, right, in my operation. I'm taking care of it by an integrated herd and by managing that herd appropriately, allowing a long rest period after an intense grazing event. Okay? That's how plants and animals evolved. Bees are the best livestock, I gotta say. So we often think of pollinators as something totally different, but I mean, honeybees are a domesticated species by their definition, and an incredibly valuable revenue stream. Not just in honey production, wax production, and things like this, but in terms of pollinating your crops. I had 2 friends grow buckwheat in on their farms in our county, and one of them outpaced the other one by twofold. They had twice the yield, and it was because he had 80 hives on his field. And so he came back at me and was like, boy, you know, I mean, you got your beekeeper friend, and he puts his hives here, he's making money off of me, I should see some of that. I'm like, no, you don't understand. You just produced twice the revenue off of your field because you had those bees. I think you're winning in this situation too. Oh, okay. Even in self-fertilizing crops, we see an up to 20% yielded bump in canola, sunflowers, soybeans. These are all supposed to be self-fertilizing, but they all see a yield bump just by having bees next to you, as long as you're not smoking them out. And that's the trick. There they are. That's your principles. What jug to put on to kill that pest? It's all right here. That's how you answer your pest problems. That's how you make yourself as profitable as possible. Tillage. Never leave bare soil. Increase plant diversity. Diversify livestock and and crops in the same place at the same time. There's the solutions to the problem. Changing agriculture. Unless we do this, the planet's going to continue to be on this trajectory. It's a really dangerous one. Okay,